All right, now we go to the metric game. Now notice, on these examples, they're already worked out for you. So you may not need to be going to this video review. Right now, what I think I'm going to do is just repeat this. Here I'm writing it down and showing you how to do it. But on the video review, I'm going to work the problem, live, or live for me, but so video, so you can see me work it. So some people don't learn this way. It's just too much information and then it gets all confusing. So if you watch the video, you can watch me do it step by step. You know what I'm saying? I might in the future say, okay, here's 4 or 5 more problems you can look at. Right now I'm just trying to get through, I have like 50 examples. I'm trying to get through all 50 examples this year. It's my goal. So I'm going to probably do it straight up as it is here, and then I'll add to it as the year goes on. So if you're looking for other examples, these are the 3 I'm going to do. And if this made sense, then you're kind of wasting your time watching me right now. Go on to example 2 if you want. Okay, so example 1, here we are, and it is, let's get off this, and I should have it down here. Let me come pick it up. It's on this page. Open recent. There we go. Okay, here it is. So here's my example. It's the same thing you see, only what I would do is either maybe follow along, but you might want to cover it up and try this. We probably either talked about it in class, or if you never had me in class, then maybe watch an example, then try the next one. So what we're going to do here is we're trying to convert from kilohertz. Now hertz is a unit of, named after Heinrich Hertz, and it's a unit of frequency. Okay, so a hertz is a cycle per second. So like a wave, when it comes, a wave front's coming at you, and 1 wave hits you per second, that's 1 hertz. This is usually in terms of electromagnetic spectrum, but also can be in terms of sound, that kind of thing. But hertz is simply cycles per second. So here we have kilohertz versus megahertz. Now kilohertz is AM radio. When you tune to say 640 AM radio, and now locally here that's a sports talk show, that's 640 kilohertz. That radio wave making those electrons vibrate, that radio wave on the antenna, that radio wave is coming in at 640, if that was that channel, 640,000 hertz per second. Now when you go to FM, like 107.7 or in KGOU 106.3 locally, that's in megahertz, so that's millions of hertz. And so a kilohertz would be, like in this case, 592. If there was a station 592 on your radio dial, that would be 592,000. That thing is moving, this electrons are vibrating at 592,000 cycles per second. That's my model of it anyway. And say I want to convert that to megahertz, and say, well, if I wanted to switch that to, for some reason I wanted to talk in terms of megahertz, how would I switch it? Okay, so we'll talk a lot later about hertz and all that kind of stuff. Little preview. Well, here's what I do. I think of the power line. So you have that power line that was on the PDF I showed you earlier, where it went from picometers to terameters, and that could have been picohertz to terahertz, picoseconds to teraseconds. That's the cool thing about the metrics, is you just switch in whatever base unit you want, MKS, meters, kilograms, seconds, and then stick on a prefix, and you can talk very easily, and everybody understands what you're saying, scientists anyway. In fact, the French Revolution, they went to this is not just a bunch of radicals and a bunch of peasants. I mean, they thought through all this back in the day, Lavoisier and all that. So the scientific method was around a bit, but they thought through this and thought, how can we make it so that it's easy to understand? We can all communicate. when, like here it's hertz, here it's meters, here it's grams, and in the French Revolution they even tried to make time metric. So they would talk about, kiloseconds, 1,000 seconds, centiseconds, 100th of a second. That didn't go over. Megaseconds, a million seconds, and it just didn't go over. A calendar can't be worked out that way because you can't really do commerce with other countries when your calendars are all different than theirs. So they dropped that idea after a while. But the rest of it stuck. So here we go, kilohertz to megahertz. So what I do is look at the power line and I look at the prefix. Well, kilo is 3, and so I'll put above it a 3 because it's 10 to the third power, all right? And then mega, when I look at that, that's 6. So I put a 6 above it because it's a million, it's 10 to the 6th. Okay, you all can do that. And then I have to, now, I need to write the answer in scientific notation. And proper grammar on scientific notation puts the decimal after the first digit. I could go ahead and say 592 times 10 to the something, and I'd be okay. People would know, what you mean, but it's kind of like in writing, you're just not capitalizing the first letter of a sentence, and it's bad grammar. So you always put the decimal after the first digit. So 5.92 times 10 to then what I do is I put a box up there so I can play my little game. So I'll make it a yellow box. I can remember how to use this thing. Alright, so I'm going to fill in my goal on my little game here is to fill in the yellow box with my answer. Well, I'm not done yet because notice that I have to take into account. See, here's the part that a lot of students have trouble with. That says 592. I can't just ignore that because I'm writing it as 5.92. So compensation. This is compensation. I have to compensate for the fact that I am jipping it. I'm moving this back 2 decimals. So if the kilo and the mega weren't there, and I was going to write this 592 as just a number with the decimal after the first digit, I would have to write it as 5.92 times 10 to the second, right? Because it's 5.92 times 100. So that's why there's a 2 that goes above that. Okay, and that's telling me that it's not 592 here, it's 5.92. So that's for me to remember that, oops, I got to make sure I keep that. Now the game is you add these up on this side. Because not only is it 592, you also have 1,000 with it, right? Because it's 592,000 hertz. So there's the 2 plus 3, puts it at 10 to the 5th. Okay? So I put the little thing there. So you add whatever your power's up on the left side. But then I want to take that and I want to move it over. I want to say, well, that's too big of a number. I want to make it so it's in the megahertz range for whatever reason. So what you do is you take these, you add these up, and then you subtract what's over here. And so on the power line, I got 5 minus 6, or my answer is -1. So it's 5.92 times 10 to the negative first megahertz. Well, that's not really the best way to write it. And we'll talk about the best way to write, just once again, grammar. I don't mind. You can write everything in terms of scientific notation. I mean, the number 6 is 6 times 10 to the 0, right? So anything can be written in scientific notation. But that just seems a little bit overkill for this number. So it's really just 5.92 instead of 91st, which is really just 0.592 megahertz. Now, I'm not going to require that you do that, but if you want to write it that way, I'm cool with it. That's fine. Okay, let's go to the next one. And here we have gigameters, and this is why it's dumb This is a dumb way to write this thing. It'd be better, I suppose, to put it in terms of micrometers. Giga is 1 billion meters. Micros a millionth of a meter. And that's the reason why. That's a really small number. So whoever wrote this, I mean, I did, just messing around, but say you read this in a book, I would put that book back up on the shelf because the person doesn't know how to use units. They're using improper units. They're having to make a really tiny number. That's the whole point with having that power line. So you can talk, you don't go and talk to somebody about, distance to Oklahoma City in terms of inches. You pick miles as your unit because it's more conversational. They see a picture in their head. They can't get the idea how many inches it is to Oklahoma City, or even feet. So it's dumb to say gigameters for such a tiny number. So it's better, maybe, perhaps, to say micrometers. I mean, we're going to try it. All right, so here we go. Here's the deal on this number. It's already in scientific notation. So I can write it as 6.51 times 10 to the box. So I don't need to worry about this little thing I did up here with the 592 because the decimal is already in the right spot. But I don't want to forget that there's that negative 13 there. Okay? Can't just ignore it. And then the giga, I'm going to put a 9 above it because on my power line, it's to the 9th power. And micro, I'm going to put a negative 6 above it because on my power line is to the negative 6. Now I play the game. I add up these powers on the left. 9 minus 13 is negative 4. And then, I'm adding them, but it's a negative there. And then I subtract over here a negative 6. So I have this is where you got to keep your arithmetic in your head. Students mess this up and get mad because they do the mess with the arithmetic. But 9 minus 13 is negative 4. Minus a minus 6 is like adding 6. That makes it 2. So once again, you could leave it as that, or you could just write it as 651 because that's 100 there. So 651 micrometers. And that's a better way to say it, right? Which is very, very tiny. 651 micrometers, that's not even a millimeter yet. You could barely, I think that's almost, you probably couldn't even pick that out. That's even smaller than a flea. It's like a head louse or something. Very, very tiny, almost not even visible to the eye. Okay, so very small. Right now let's go to the third one. And this one is nanograms and working our way to milligrams, and they're a very particularly nasty problem here because we got all this to deal with up here as well. So let's go ahead and write it in the proper notation, proper grammar. 4.9 times 10 to the box. We have milligrams over here, which is negative 3 milli. We have nano, which is negative 9. You see where you start working all these? I'm going to give you another worksheet later on where I just want you to practice, practice, practice. There's not a whole lot of things in the class you want to commit to memory. In fact, if you're in my class, that's always going to be up there all year. You could always look up there, but I'm hoping that over time you'll eventually just kind of know these just for use in my class all the time. And now I have that 15 I've got to remember. That's no deal, no big deal, I'll just circle it. And then we got this guy. Well, to go 4.9, I'm really I'm moving that thing 1, 2, 3, 4 decimals over. And I'm really saying I have to compensate because this is a big number. That's actually a really tiny number. I have to show that I'm really dealing with a pretty tiny number here. So it's going to take away from some of that 10 to the 15. It's going to take, see where you're going to subtract it. So you're going to lose some of that massiveness. The 10 to 15 sounds huge, but I took away a little bit. So I moved the decimal 1, 2, 3, 4 places. So that's 10 to the negative 4. Okay? Think of it in terms of size. So now I play the game, and the game is to add all these up over here. So 15 minus 9 minus 4. That's like 15 minus 13, or 2, right? So I have 2 on the left, and then I subtract on the right. So it's 2 minus a minus 3, which is like 2 plus 3, so that should be to the 5th power. All right. So the answer is 4.9 times 10 to the 5th. Go ahead and highlight that. Highlight my answers. And there you go. Example 1, the metric game is conquered. Now example 2 comes on the next page, which we're not quite at yet. So I'll hold off and we'll mess with that next time. Hope that helped.